So I'm sure all of us are aware of what absolute value is. If you're not, then this probably isn't the video for you. Today I want to find a sort of multiplicative analog to absolute value. A sort of multiplicative absolute value, as I like to call it. So basically our goal is to find a function f that maps from the two-dimensional integers to the two-dimensional integers, and that's basically just saying two integers, such that f of p and q, where p and q are integers, is p over q if p over q is greater than or equal to 1, so it's just the same thing, or it's the reciprocal if p over q is less than 1. Okay, there are a few different ways to phrase this, but first I want to talk about the greater than or equal to. We could say if p over q is equal to 1, then p over q is equal to 1. It's not that interesting. We can just combine it here, because if p over q is equal to 1, it's not that interesting. So we can just kind of like put that in there, okay? We could phrase it differently. We could think of this as, we could say find f, from q to q, right? And then we could say f of, I'll call the rational number r for rational, because I already used q. F of r equals this, so r if r is greater than or equal to 1, or just 1 over r if r is less than 1. We could totally phrase it like this. I just like to do it with p over q, p and q, just kind of, it looks a little nicer that way. We could actually also write this as f mapping from q squared to q squared. But that's kind of redundant, because if let's say p is in q and then q is in q, both are rational numbers. If we have p over q, we can think of this as p as a over b, and then q as c over d. This is just a whole new integer, because this is a c over bd, right? No, this is embarrassing. It's ad over bc, right? We can just think of it that way. I'm paranoid that that's wrong now. But yeah, so that doesn't really matter. So this case is valid. This bottom case, it is another way you could say it, but it doesn't really make sense, because it's just like this is an integer over another integer, and that's not very different than saying this or that. And technically we don't have to restrict to the rational numbers. We could totally just go with real numbers, and then just, this would make more sense in that regard anyway. We could just replace the q with an r, r for real numbers, which again, it's totally fine, and we could totally do that. So let me just replace the q with an r. So yeah, this way it's a little more restrictive, just with z squared or q, but this way, I mean, like, I like to think of it as we're dealing with rational numbers when we're doing this multiplicative thing. So to me, I like this better, but this is totally acceptable. And later, whenever we look on Desmos, it's going to be real inputs. It's not going to be rational or integer inputs. So, and yes, later we will look at Desmos for this. So let's just construct the function. So yeah, we can basically just leave these different alternative definitions in the back of our mind, and just say, it doesn't really matter as long as we're all achieving the same sort of thing. It's all good. So, what can we do to figure this out? So what I want is some sort of way that we can tell whether something is negative or positive, because, like this, we could just shift this over. So saying that p over q is greater than 1, we could say p over q minus 1 is greater than or equal to 0, and then equivalently we could say p over q is less than 1, just means that p over q minus 1 is less than 0. And this is really good, because now what we have is we have like a sort of like a sine function sort of thing, because we can really utilize that. And one remark before I get there, we could think of this as the absolute value of these, and I'll show you there's a very subtle difference in if we consider just the absolute values, if the absolute value of P over Q is greater or less than or equal to 1. But for now, let's just focus on if it's not, because that's fine. It's fine if we have negative outputs for this. We're not looking for just positive outputs, we're just looking for outputs that are greater than 1 or less than 1, right? Or, well, greater than 1 always, because this is always going to be greater than 1. So yeah, or equal to 1. So yeah, so we'll look at that later, but basically we can write it like this, okay? And so we can have our input, so let's take our input, so let's say, I'll explicitly write it down, so f of p and q, where again p and q are integers, so this is going to be, we're going to take p over q, and it's actually pretty basic. We are just going to use the sine function, so remember, the sine function, not sin, but sgn, is just absolute value of x over x. And this is either positive 1 or negative 1. It's positive 1 whenever x is positive, and it's negative 1 whenever x is negative. And that's because if you plug in a negative number down here, it's negative, and if you plug in a negative number up there, it's also it's positive. So positive divided by a negative just gives you a negative. So this function just looks like, if we draw, it's going to look something like that, and that goes off to infinity. And of course at 0 you don't have a solution, unless you define it that way, which you could. But for our reasons that's not important. Okay, so we're going to take p over q, and let me write this a little nicer. And then we're going to take it to the sine of p over q. Alright, sorry, I just needed a lot of vertical space here, because the power is going to be pretty, it's going to be a pretty big power. So the power is going to be the sine of p over q minus 1. So we're going to take p over q, the absolute value of p over q minus 1, and then divide that by p over q minus 1. And so f of p over q is p over q to this crazy power, absolute value of p over q minus 1 over p over q minus 1. And the difference, if we cared about the absolute value, was that these parentheses would just turn into absolute value bars. And that's the only difference. And you'll see on Desmos that this really is the way it works. So let's just head over there right now and look at that. Actually, one more thing before we do that, just one final remark. If we just used our other definition of just like the rational, like f from q to q or from r to r, it would just be f of r equals r to the absolute value of r minus 1 divided by r minus 1. And I think that's a lot more pleasant, but this, I like this idea better, but I also like this idea better. So it's up to you however you want to think about it. But yeah, we'll get straight into the other part of the video now. Okay, so here I have basically everything that I was talking about earlier. So I have p and q. They're not necessarily integers in this case, but it doesn't really matter. It's just a continuous version. So we have p divided by q and q divided by p. I just wanted to show them both there. And then here I have this function t, which basically is what I was saying earlier. So you have p over q to this crazy power, and so t can be positive or negative. Then I also have s here, which is the absolute value. It's like the absolute value version. It must be positive for every value that you choose of p and q. And so you can see that everywhere there's a p over q in this t equation, you just put absolute value bars around that. So you have like these double absolute value bars in the s equation. And then I wanted to show what t minus s is. So right now it's 0, since they're both positive. So here, let me just show you. So actually, let me pause this a little bit. So there, we can do something like that. And so you can see p over q and q over p. You can see t here. So you can see that it's sometimes negative, sometimes positive, and then here s, you can notice, is always positive, regardless. And so then t minus s, it shows it's going to be 0 whenever p over q is positive, right? So if p and q are both negative or both positive, then p over q is positive. But of course, if one of them is negative, the other is positive, then p over q is negative. and so then thus you'll see that there's going to be a difference in t minus s. So whenever they're both positive or both negative, t minus s is going to be 0. So I just wanted to show this to show how it kind of works for varying values. I also wanted to show, I wanted to use the variable r, but Desmos like sees that as r for radius, so I'm going to use the variable s. I'll just say s equals 1, and then I'll show what 1 over s is. And then I want to show the other equation with like the the whole real number thing. So it's going to be s to the s minus 1 divided by s minus 1. Right now it's undefined since you'll have this 1 minus 1 at the bottom, but you can see that it works. Like it's fine. You have like a whole different thing. And of course you can put the extra absolute value bars everywhere. But again, I don't really think that's much of a big deal. I just wanted to really discuss the multiplicative absolute value. I think that's all I wanted to say about this. I didn't really want to like say much else. I don't really know what else to say, but this is a really interesting thing that I thought about the other day, and I just wanted to share. So if you find this really interesting, then I'm glad you enjoyed. So thanks for watching, and I'll see you in the next video. Bye, guys.